All right, so we are on our final and probably most fun, and I say that with the utmost sincerity, I promise, section of this unit, which is completing the square. Okay? And try and have fun with it. I know it's going to seem like a lot. At any rate, so by the end of this, you should be able to determine the value of c when completing the square, identify all of the steps when completing the square, solve for x when completing the square, and finally, identify and interpret the maximum or minimum of a quadratic in a real-world context. All right, so completing the square is a good method to solve for x when you can't factor. I mentioned that in the video about factoring. It's not easier to execute than the quadratic formula, but it's not hard to remember what you need to do. Okay, so you have this. The first thing you would do would be to subtract c from both sides. So let's go through this. So if I had ax squared plus bx plus c equals 0, the first thing I would do would be to subtract c from both sides, which gives me ax squared plus bx equals negative c. Next, I would take half of b and then square it, and then add it to both sides. So basically, I would take b, so we'd say, okay, so this is b right here, not the x, just the b. We'd take b, we'd divide it by 2, and we'd square it. And whatever that was, we would add it to both sides. Then we would convert the left-hand side to squared form and simply simplify the right-hand side. Then we would square root both sides, remembering to do plus or minus on the right side, because we were doing the square root, and then we would solve for x. Unless we were trying to find something in vertex form, and then you kind of go from this step, and then you just move the right-hand side back to the left-hand side, leaving the right-hand side as 0. But all of these words mean nothing unless you actually do them, because you're looking at this wall of text thinking, why? Why would he do this to us? And that's when I bring up example number 1. So, we're going to start you off easy. All you need to do is determine the value of c. So we are going to take that, okay, x squared plus 14x plus c. So we're just going to do it some baby steps. First things first, remember that this is your b, and that remember what we do with the b. We take our b, and we divide it by 2, which we did right here. 14 divided by 2 is 7, which we then squared to get 49. So c is 49, because remember I wrote that as b over 2 squared. So that's 14 over 2 squared, which simplifies to 7 squared, which is 49. So it's basically the same way of doing it, just this way on the left is kind of like how I usually do it. This just explains it. Now we need to solve for x by completing the square. So we're going to go ahead and take this a little bit further. So we're going to do what we just did. We're going to go ahead and but before we do that, we need to subtract 26 from both sides, because remember c we take away from both sides. So we go ahead and we do that, and we end up with x squared minus 12x equals negative 26. So this step, we took away c from both sides. Took c from, sorry my writing is weird today, I don't know why, from both sides. The computer's running choppy. Okay, next we take half of b, so there's our b, negative 12. Notice I took the sign to the left of it. We divide by 2 and we square that answer. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. Please note, when you do this, okay, b divided by 2 squared will always be positive. Because when you square something, it doesn't matter if it's positive or negative, it ends up positive. So we take that and we add 36 to both sides. Okay? Simplify the right-hand side. Negative 26 plus 36 is 10. And then we're going to, since this here, this is always going to be basically this term squared with this sign. So if it's plus, it's going to be plus. If it's negative, it's going to be negative. So you take this part of it, and that goes there, okay? And then you take the square root of this, and that goes there. Okay, just kind of an easier way, whoa, I don't know why that's writing all over. Kind of an easier way of remembering that. And then to get rid of the squared, we have to square root both sides, because this square will remove this, this square root will remove the square, but since we're square rooting this side, we have to square root this side. And since we're square rooting it, this has to be a plus or a minus. Okay, so that's where we're going to get our two answers. So that becomes x minus 6 equals plus or minus the square root of 10 because we don't know, like square root of 10 is an irrational number. So what we end up with is we have to add 6 to both sides to get rid of it, right? We can't add these two together, so that's got to just be rewritten as 6 plus or minus the square root of 10. And then even though technically that's not an incorrect answer, we're going to separate it out like this. Okay? Next example. Now, you might look at this problem and be like, hey, you don't need to complete the square on that. You can factor that. And you are absolutely right. Good job if you saw that before I said it. However, I just wanted to show you that, one, if I asked you to complete the square, you must, even if it can be factored. So you have to do as I say. And two, just showing you that if you somehow miss that it can be factored, you can complete the square and still end up with the correct answer. So that's actually the more important reason, not the power-hungry reason I gave for the first one. So start off, and again, subtract c from both sides. Here's your c. Subtract that from both sides. Okay? So negative 15, so we subtract 15 because we had a positive 15 from both sides. So we have x squared plus 16x equals negative 15. Okay? Next, I want you to take half of my b. Here's my b, remember? So I'm going to take half of 16, and then I'm going to square whatever that answer is, which is 64. So I add 64 to both sides. Okay, and remember that I take the first part of this, and that goes in here, right? And then the square root of this number, and there will all, if you did it right, there's always going to be a square root of this number, and that goes there. In the parentheses and square it, and then just combine these two, and you'll get your one number over here. And then we can't have that squared. We have to square root it. So since we square root that, we square root both sides. Don't forget this. This is very important. I'll even take the time to write. Very important. Okay? Very important. And I even added 3 exclamation marks so you know it's true. All right, and you might say, hey, square root of 49, I can actually find that, which you can. Super. So you have x plus 8 plus or minus 7. You still keep that plus or minus. Okay? And so again, we are going to try and isolate that 8. So what we really have is x plus 8 equals 7 and x plus 8 equals negative 7. So we're going to have to, in both cases, subtract 8 from both sides to cancel out on the left side and get x by itself. So we have x equals negative 8 plus 7 or x equals negative 8 minus 7. And when we, you wouldn't actually write it like that. You'd write it like this. X equals negative 1 or negative 15. And I'm sorry, I don't know why this isn't erasing. But so your answer is x equals negative 1 or x equals negative 15. Sorry. So that's your answer. Third example. Fourth example, we have the number of bacteria in millions in a refrigerated dish, and it's given by the formula n of t equals t squared minus 8t plus 6t, where t is the temperature of the food in Celsius. And Celsius is misspelled. Shame on me. Use the completing the square method to determine the temperature where the population of the bacteria will be a minimum and the corresponding number of bacteria. So basically, remember, if it says we need to find a minimum or a maximum, what we're really finding is the vertex. And you're like, but completing the square gives you your x's, not your vertex. But I'm going to counter that with, you can find the vertex, trust me. Okay, so let me take you on that journey of finding the vertex. We take our formula. Okay, and yes, it's n of t, it's not equal to anything, but we're going to go ahead and we're going to set it equal to 0 so that we subtract the 60 from the both sides like we've done. So like we set it equals 0, subtract 60 from this side to get this. And then we go through, okay, half of this squared, and we're adding that to both sides. So half of the 8 is negative 4, negative 4 squared is 16. So what we really have, and I'm going to back it up a little bit. So what this gives you is t squared minus 8t, because I'm trying to simplify steps here, plus 16 equals negative 60 plus 16. Now again this, so we're taking this first part and it's going to go inside parentheses. Okay, so that t squared minus part. Then we're going to take the square root of this. Square root of 16 is 4. Negative 60 plus 6 is negative 44. And don't forget, this is squared, so it's not t squared. I should have mentioned that. You lose the squared part. The squared goes outside. So that's t minus 4 squared equals negative 144, or negative 44, which is where I got that. Now, when you are not solving for x, which it doesn't say anywhere in there to solve for x, it says find the minimum. So here's the easy part. When we have to find the minimum, we put it into vertex form. You want to know what vertex form looks like? Vertex form looks like this. You take this t minus, so here's vertex form, is f of x equals a, if you have one, x minus h squared plus k, where hk is the vertex. You're like, well, how does that relate to this? Well, remember, this is all, I want to get this so that it kind of looks like that. A is your lead coefficient. We had a lead coefficient of 1, so that's not going to matter. But when I rewrite this, I can make this look like this. All I have to do is add 44 to both sides. Because now it's equal to 0, and now I can just say, well, n of t could also be t minus 4 squared plus 44. Oh, look at that. So the thing to remember here is your vertex. So your k, your y value, this is k and y are basically the same thing. This is your y. Your x is this, not the sign. This is the one time, well, not the one. This is one of the one times that you don't look at the sign to the left of it. So your vertex is 444, which, remember, in a parabola is either the maximum or the minimum. In this case, it's a minimum because your lead coefficient is positive. So we end up with that, like I said, plus 44. So your vertex is 444, which means instead of x, we have a t. And t was the temperature of the food, so that's a 4. So at 4 degrees Celsius, there will be 44 million bacteria, because remember, this number was in millions. Last one's very much the same thing, except now we're only asking about the units, and that's it. We're solving by completing the squares. So x squared minus 10x plus 30, we're going to set it equal to 0. We're going to subtract 30 from both sides, just like we have been. All right? And then we're going to take half of the b, which is negative 10, and we're going to square it and add it to both sides. So half of negative 10 is negative 5. Negative 5 squared is 25. We're going to take the x, the minus sign, and we're going to put it inside parentheses. And then we're going to take square root of that and put it inside the parentheses, and we're going to square the whole thing. Okay, which is where I got that. And then negative 30 plus 25 is negative 5. And right now you could stop, because you could be like, well, I know that all I'm going to be doing, like if I want to put this in vertex form, which is, again, we're talking about minimum. If it said minimum, minimum. If it's maximum, maximum, whatever. We're talking about the vertex, and vertex form for this would be c of x equals x minus 5 squared plus 5, because we'd add 5 to get to both sides. That's vertex form. So where you're seeing that on your papers, that's what you're going to do there. So you're going to get to here, and then you're not going to solve, you're not going to square root both sides. You're just going to add that back over to the other side and call it a day. Okay, but now we're being asked how many units should be produced. Units is x. Okay, x is the number of units produced, which in this case is a 5. So it's 5 units, because remember, for this, we only look at this. If this was a plus, then this would be negative 5, and it wouldn't make any sense. But we'll cover that more in class. This is more a supplemental to class. But if you're not a student of mine, hopefully it has been helpful to you. And if you are a student of mine, hopefully this is ringing some bells for you. So if you have any questions, as always, let me know. And you guys have a lovely